Hello everyone. In this video, I'm going to show you how to interface LED array to AVR microcontroller. So to interface LED array, we are going to use ATmega16 AVR microcontroller, and to write the code, we are going to use one software, that is mikroC Pro for AVR, and for simulation purpose, we are going to use Proteus software. So we are going to write the code in mikroC Pro, and simulation we will see in Proteus software. This is my ATmega16 chip, microcontroller chip, where we are having four ports: port A, port B, port C, and port D. These all ports are used as input, output, or for a special purpose. So I'm going to use port A for LED interfacing. So I'm going to connect 8 LEDs to port A, that is from port A0 to port A7, that is pin A0 to A7. First, I have connected one LED to pin number 0 of port A. Here I have connected the anode terminal to pin and cathode terminal ground. Now to glow this LED, to on this LED or to glow this LED, see, this is already connected to ground, that means it is 0, so connected to 0. Now to glow this, anode should be port pin 1 high. So when it is high, so this LED will glow. So to glow this LED, we have to pass the or we have to make this port as high. I have connected 8 LEDs to port A, that is from pin number 0 of port A to pin 7 of port A. All anodes are connected to pin numbers and cathodes are connected to ground. So to glow this LED, we have to make this pins of port A high. Now to configure, how to configure that particular port as input or output. Here each port, four ports A, B, C, D. So each port consists of three resistors. First is DDR, second is port, and third is pin. So here DDR-X is representing data direction resistor. Then port is stands for pin output register, and then pin is pin input register, and where X is representing port name A, B, C, D. So here data direction, it is used to set the direction and used to configure the input output port. Then for making for input, make it low, and for output, make it high. So when you are going to use any port as input port, so pass the value or make it low, and if you want to make it output, so just make that particular port or pins high. Then for next is port, the value which are to be supplied at the output of this port are written in this register value. Then pin, whenever the port is used as input port, so this pin is used, which this register stores the input value from the external connected hardware when the port is configured as input port. So all LEDs are connected to port A, that means port A act as output port. So we are going to write one program to blink the LED continuously. So here first is hash include AVR oblique io.h. So this is the header file for AVR microcontroller, which is nothing but input output header file of AVR. Then this is the delay header file, util delay. Then void main start of main program. Then ddr a is equals to 0xff. Now here see, as I have said that to make the any port as output port, pass the make it high. So ddr a is equals to 0xff, means now all pins of port A is used as output port. So make it high. So all pins 0 to 7 will become 1. So this 0x representing hex number. So convert this binary number to hex. So this is nothing but 15, and this is nothing but 15. So 15 is in hex, 15 is representing by F. So here I have this 4 points become F, and this become F. So here the value I have passed FF. So here it means that this particular port is used as output port. Now we have only configured the port A as output port. Now we have to pass the value. Now we have to blink the LEDs. That means all LEDs should be 1, and then after some time all LEDs should be 0, and continue. We have to make this sequence continuously. So for continuation we are going to use while one. And so this is infinite loop, while one loop, and then uh, port A is equals to 0 0. Now pass the value 0 0 0 0 0 0 0 0. Now all LEDs will be off. So here this is representing hex number, so here it is equals to 0 0. And then after some times, now this is delay ms 500, that means it is generating 500 millisecond delay. Now we are not using any timer or inbuilt delay, we are just using software delay. So this is called as software delay. So delay ms 500 millisecond delay. After 500 millisecond, all LEDs should be glow. To glow this LED we have to make it high. So all pins will be 1 1 1 1 1 1. So that means this is nothing but f, and this is also f. So here pass the value 0x ff and call the delay, and this will be continuously blinking the LED and end of the main. We have to generate the different sequences. So how to generate different sequences? Here the program will be same till the while loop. So here include a header file, input output, a standard header file of AVR, then delay header file, then main program, then DDR A is equals to 0xff as port A is using as output port, then while one, then port A is equals to f0 of this 4 LEDs, and then on this 4 LEDs. So this will be all LEDs should be off, and this LED should be on. And after some time, this will be on and this will be off. So how to pass the values? So here see upper 4 should be on. So upper 4 1 2 3 4, pass the value high. So after so it will be glow, and when I will pass the value 0, it will get off. So here the value is see, this will be f and this will be 0, and next time make it high 1 1 1 and make it low. So the value will be f0. So first I have passed the value f0, and then next time I will pass 0f. So any sequence you can generate, you can pass for first 0f or f0, and next time f0 0, end of the main function. Then similarly you can generate the different sequence, you can alternative on and off the LEDs. So how to write the code for this? Just calculate the value. First it will be 0 1 0 1 0 1 0 1. So here this will be equals to, say, this will be equals to a, and next time it will be 0 1 0 1 0 1 0 1. So this value will be 5 5. So pass the value. First header file will be same, AVR input output header file, then util delay header file, main program, then DDR A is equals to 0xff, that is configure port A as output port while one, then port A is equals to 55, then next time pass the value port A is equals to AA. So here alternative on and off the LEDs, and the call delay and end of the while loop, end of the main loop. So similarly you can generate a different sequence. Now if you are facing any problem to convert this binary number to hex, you can directly use the binary number here also. See, this is representing hex number. Just write see 0 b, this is binary number representation, and write this value 1 0 1 0 1 0 1 0. And in here also port A is equals to, pass this values, okay, 100. So instead of write converting it into hex number and then writing, you can use directly binary numbers also. And similarly you can generate the different sequences. Hope you have understood how to generate, how to interface LED arrays to microcontroller, and how to generate the different sequences. Now we will write this code. We are going to use mikroC Pro for AVR. So here I'm going to make first a new folder on my desktop, and I will write the practical practicals, okay, and I'm going to save my programs in this folder. So just double click on mikroC Pro for AVR software. Click on new project, then standard project, click on next. My project, give the name LED array. Save in your folder. My folder is on desktop, that is practicals. Open this, save here. Make sure that device name is selected ATmega16. If you are using any other microcontroller, you can select here from device name. So I'm using ATmega16, so here I have selected ATmega16. Click on next, and then finish. Okay, software, you don't need to write down the uh, header files. Start the program from void main. So I'm just going to copy this program and going to paste over here. Save this file. Save, give the name, I will give the same name, LED array. Save this and then build. Okay, so after building, check it's in practical. Here hex, yeah, see here hex file is generated. So this hex file I'm going to use in my Proteus software. So just open the Proteus software, click on new project, then this will be LED array. Select the folder where you have to save this. I'm practical folder only. Next, then select default, click on next. Do not create a PCB layout, click on next. No firmware project, click on next. Finish. Now here design your circuit. So click on P, that is pick device. Type your ATmega16, whatever components you want. Click OK. So this is my ATmega16 microcontroller. Then click on LED. Select animated LED. So these are the animated LEDs. So from this you can select anyone. I'm going to use this animated LED model. So just click here. So now rotate it clockwise and then copy it and then paste 8 times. 7 and 8. Now connect all 8 LEDs to port A. So this is my port A. Okay. Now from terminal, select ground, place the ground here and connect all cathode to ground. After connection, to load the hex file, just double click on this chip. After double clicking, select your folder where you or saved your hex file. So here in practical folder, one my LED array hex file is there. So just open it. Okay, and then run this. LEDs are blinking alternatively. First this will be, see here, after some time it will be on and this will be off. Okay, so you now similar manner you can generate any sequences, and this is for simulation purpose. In actual hardware you have to connect the resistor between this anode and the pin numbers. So connect the resistor here of 330 ohm. This can be used for simulation purpose, but in actual hardware you have to connect the resistor here. Okay, so hope you have understood how to generate the different sequences and how to interface the LED arrays to AVR microcontroller.